Hello, my name is Vera Panova and I'm a second year chemistry student here at Cal Poly.
My name is Tatiana and I'm a second year physics major. So today we'll be working through problem 15 from section 6.1 in the general chemistry workbook. You should begin by working through the problem yourself and then watch the video afterwards so that we can work through it together. So first, let's determine what we will be solving for in this question. We're being asked to find the frequency of a microwave. So right away, we can think that maybe a good relationship to look at is energy is equal to Planck's constant times frequency. This is an H right here. And this V value right here is actually nu, and that's what we're solving for. So we can rewrite this equation as nu, the frequency, is equal to energy over Planck's constant. So right away, we should look at the given values that we already have. So our total energy, I'll highlight right here, is 2.95 times 10 to the 5th joules. And that's the combined energy of all the photons together. So we need to keep that in mind. We're also given the amount of photons that hit the cup every second. So we need to make sure we're taking account of that. And then our total time is 2.4 minutes. So with that, the first step we want to take is to determine how many photons in total hit the cup. The way we do this is by starting out writing a little dimensional analysis problem where we start with the 2.5 times 10 to the 4th photons that are emitted every second. So we write that as a ratio like that. Times our conversion factor of 60 seconds to 1 minute. There's my 1. And then we're given a time of 2.4 minutes. We write that over 1. Then we can therefore solve that dimensional analysis problem by first confirming that all our units cancel out and we want our final product to be photons. So let's see if that works. So we have seconds here and seconds here, so those cancel. Minutes here, those cancel, and we are indeed left with photons. And when I calculate this number, our final number would be 3.6 times 10 to the 26th photons.
So now that we know the total number of photons in the 2.4 minutes, we can find energy of one of those photons. So we'll take the given energy, which is 2.95 times 10 to the 5th joules, and divide it by the total number of photons that we just calculated, which is 3.6 times 10 to the 26. So we get 8.19 times 10 to the negative 22 joules per one photon. Now we can go back to our energy relationship with the frequency and plug in the values. So our nu equals this energy per one photon, which is 8.19 times 10 to the negative 22 joules, divided by the Planck's constant. And this is just a constant, it's 6.626 times 10 to the negative 34 joules second. And we can see that the joules will cancel out and we will be left with units of 1 over second, which also equals to hertz. So the answer would be 1.24 times 10 to the 12 hertz. So we can leave our answer as such, but we can also convert it to gigahertz because it's such a big number. In order to do that, we'll just use a conversion factor. We'll put hertz into the denominator so they would cancel out and put gigahertz in the numerator. So in 1 gigahertz, we'll have 10 to the 9th hertz. So now the hertz will get canceled out with hertz, and we're left with 1240 gigahertz. And this will be the final answer.
So please make sure to include the units in your final answer, and if you came to a different final answer, please just check your work again against our own, and we hope that this tutorial has helped. Thank you.